What's up, y'all? We are back in the lab. I got another video for you guys. It's been a while since I've put a video out. Just been busy with work. My schedule sort of shifted to more of a 9 to 5 type deal. Makes that harder to record these videos, but I thought this one would be pretty interesting. Let's just dive right into it. So this is a Beckman Coulter Optima L-80XP ultracentrifuge. I've done a video on repairing an ultracentrifuge before, the switch mode power supply that drives the thermoelectric module and some other circuitry, embedded PC. This one appeared to have had a similar issue, at least at first glance. An end user was trying to run on it. They got it up to about 3,000 RPM, and then all of a sudden they lost power completely. The display went blank, and power cycling it, flipping the power switch back on did not resurrect it. So decided to take a look at it. Now, pop the front panel off. These boards had no power at all. And so my initial thought is it must be the switch mode power supply. So the switch mode power supply in these is in the back of the unit. I actually have it pulled out here. It's very similar to an old school PC power supply, providing 12 volts, minus 12 volts, 5 volts, minus 5 volts, 3.3 volts. Now that is for the embedded PC, which I have an example of up here. And also it drives the main CPU board. So that's what they refer to this guy as. This takes 12 and 5 volts, and that is coming from that power supply. So if this guy goes down, you're not going to have power to any of these boards. Well, at least to control them, the driving circuitry. So popped that guy out, took a look at it. I popped it open, and sure enough, there was at least one bloated capacitor. I believe it was filtering the 3.3 volt rail. Replaced that, popped it back into the unit, and still nobody was home. Now, I probably should have started my investigation by checking to see if the power supply itself was getting power, because it wasn't. And power for the mains voltage for that power supply comes from this connector right here. All right, so it's fed 230 volts roughly, at least for this unit. Comes from this connector and goes out to the back to the switch mode power supply. I was only measuring 140 volts there, which was quite interesting. And so that led me down started looking at the unit from the back, and I found something very interesting. And so let's take a look at that. One thing I forgot before we look at the back of the unit and I show you what's going on, this is not the original display interface or human machine interface, HMI, whatever you want to call it. This is from an older generation unit, the XL series, and this is originally the XP series. This is the original HMI with a touchscreen LCD display or LED display, and an embedded PC that runs Windows XP. There's some software that proprietary software that allows you to control the unit. I popped this guy on because I must have been having a brain fart, and I still hadn't checked for the input voltage to the switch mode power supply, and I thought, well, maybe it was an issue with the embedded PC. And I just popped this guy on to troubleshoot it a bit further. And actually, sure enough, this guy did power on just fine, because it does not require the switch mode power supply. It's getting its voltages from the some transformers that are behind these boards. All right, so but yeah, just that quick note. All right, so we're looking through the back of the centrifuge, and that is the main power switch. So you've got line voltage going in, load coming out, and so you've got these two, your live and neutral connections, which connect to this capacitor. Okay, this 10 microfarad cap, and then of course you've got additional neutrals and live wiring on the load side. And look at this. Sorry, my camera. This guy was burnt pretty badly and was no longer connecting to this cap, but that was it. So the cap tests fine. It measures the low ESR, capacitance is fine. So I don't think it has anything to do with the capacitor. I might just replace it just to be safe, but something else was causing that wiring to get so hot. Maybe it's just over time. I mean, this thing is very old. This area probably gets very hot. All right, so we've got the original interface hooked up. Moment of truth, let's power it on, see what happens. Oh, there we go. Or not. So normally these boards should be on, and they're not. So that's a bit odd. Not sure what the deal is there. Maybe I missed something. Forgot this power cable. So maybe that'll do it. Alright, so we are back. The saga continues on this one. As you can see, the older controller, the XL series controller, is back on the unit, and I will go into that in a second. So where we left off, it's been a couple days since the last segment of this video. Got the XP controller to boot up, but we didn't have power to the system control board and the motor controller board with the low voltage power. And so when I plugged that connector back in and booted the unit up again, started getting this error for basically stating that the CSC folder was corrupt or could not be found. So that's a folder in the Windows directory that is used for storing network files offline, so that you can view them offline. Not really applicable to this instrument at all, but that was a new message that wasn't occurring before this power failure. And so I decided to do a disk check that was only able to run on the next boot up, and when I did that, got a pretty serious message on boot up, which I will embed, basically stating that the system file in the Windows directory was corrupted or lost, and that Windows XP might need to be installed again, or that the hard drive had failed. And so that is why I have the old controller back on here. Now, I'm going to are going to collaborate with my IT department to kind of look into this a bit further, just to kind of check the health of the hard drive. But this seems to be an issue that pops up with these. At least I've seen it happen twice. So this is a message that I popped on the original hard drive to this guy that is with the same issue, So at some point in time before my time here, the computer assembly needed to be replaced, and it may have been for that reason, but they kept the original parts. So yeah, so this has happened before with the XP controller. But anyway, we're gonna just take a look at that, see if we can salvage the hard drive. But this is my backup plan, and it's working. It's doing a run right now. It's about almost an hour in, and it's working fine. Now there are a couple issues. So one, you can see the display is a little wonky. That's the best I can get it, and with these XL CRT-based displays, you do have controls on here to adjust the horizontal and vertical, as well as your focus and brightness, but none of those controls help to bring it back, get it perfect in the vertical. And so I'm thinking there might be an issue, a minor issue on the CRT driver board, which appears to be this board right here. And you can kind of see, I don't know if you'll be able to make this out. So you can kind of see that cap right there with 15 on it. I can't really get it at a good angle, but it does look a bit bloated. And so it could be a bad cap or something else on this board that is causing that issue with the display and the vertical. And so if this becomes the permanent fix, I'm gonna definitely look at that. But there's also obviously this fan so I got this used, this whole assembly. I'm glad I did, but just thought I could use it for parts or as a backup. This instrument is getting discontinued soon, so there will no longer be spare parts for it by probably the end of this year. So I got that with that in mind. And, but as you can see, this cooling fan, don't know what happened to that, but I'll replace that as well. This printer doesn't work, but we don't really need it. We're not we don't use this in a regulatory environment where we would need that kind of documentation, so not too concerned about that. But yeah, another problem that isn't related to the XL controller is the vacuum. So you can see here we're measuring 19 microns. This unit started developing about a month or so ago this error 41 that would pop up during runs, which is basically just stating that the vacuum is between 20 and 750 microns. It's not an error that's enough to prevent the unit from continuing the run, so you just have to acknowledge it and it'll keep going. But as you can see, this vacuum, it's hovering around the low end of that spec. And so I've done a couple things already to try to remedy that. One, I basically refurbished the pump, got a service kit from Medexin, and basically rebuilt the thing, assuming that had never been done before. Replaced the vacuum hose, which was in really bad shape, had a lot of cracks in it, and then also changed the oil for the rotary pump and the diffusion pump as well, and it has not made any difference. So yes, there could be a leak going on, but also you can see you've got this solenoid, this vent solenoid, and I decided to hook up a gauge to this and manually open it, and with the vacuum running, I can measure a vacuum as low as 4 microns. So I'm wondering if this could be a calibration problem. The problem with that is, and I may have went over this earlier in this video, but I have no means to calibrate the unit using either this controller or even the XP style controller. Apparently, I've heard this from colleagues that you need a L series controller to calibrate these, and those are the ones that just have a 7-segment LED display and the buttons, and you can key in a service code to put it into calibration mode to calibrate it. And I've been looking into possibly getting one of those so I can give that a try. But yeah, and then of course we can just kind of take a little bit of a tour. So as I've stated, this is the motor controller board. You can see you've got 3 transistors here, 3 down here. So this is a 3-phase H-bridge inverter to drive this motor. Now these transistors, you might be thinking, these look really small to be driving a motor that needs to be equipped to handle such a heavy load, run at such a high speed. These are not the main power transistors. If you look on the back, we'll take a look. They've got these really big, beefy Darlington, dual Darlington pair transistor modules that are the main power transistors to drive this motor. All right. So here is the other board that's driving some of the other peripherals, high power peripherals, such as the vacuum pump, the Peltier thermoelectric module to heat and cool the chamber, door switch, vent solenoid, diffusion pump. So that is all being controlled via this board. You can see that you've got the big relays here, and this is, you can't really see it, but you've got some cooling fans here. For the Peltier module basically sits in this area. But we can take a look at the back really quick as well. Alright, so now we are looking at the back, and it's very loud back here with all the fans going and the pump going. So let's start here with this transformer, which is providing a lot of the voltages to drive those 2 boards in the that I was just showing you guys. Now, this is where the the switch mode power supply would sit. Now, I initially said maybe this capacitor where we found that burnt wire was EMI filtering. It doesn't seem like that's the case, because actually I can't really get a good angle of it, but literally right behind this plate there is an EMI filtering module, and that makes total sense because this is the mains power cord. So that's actually sitting right here. This is probably more likely arc suppression for that power switch. That could be it, and that could explain the resistor that's across it as well, but I'm not 100% sure, but that's just a guess. You can see some very large capacitors. I believe that large one is across the bus voltage for the motor, and that, if you guys can see, but this is the 3 dual Darlington transistor modules that are the power transistors that are driving this motor. I mean, look how big those things are. But yeah. And then look at the size of these brake resistors. So on Beckman's newer ultracentrifuges, I believe they do utilize regenerative braking. So here we're still using good old dynamic braking. Yeah. Alright, so we've got the CRT out of the unit, and we've also got our driver board. So just a quick look here. This is the Dutronics. That's the manufacturer. Model BCX590, manufactured in October 2000. So this thing is 25 years old. I actually thought maybe it'd be older. And you actually can find a little bit of information on this. This actually comes as a unit. So the CRT and the driver board together from Dutronics. And I can even pull up a little data sheet that they have on here. on basically, I don't see the model that, so we had the BC 590, this is the BCX 590, but yeah, it does look, so horizontal 15 to 25 kilohertz, sweep rate or scan rate, and then the vertical is much lower at 47 to 82 hertz. Let's see what else we've got here. High voltage 13 kilovolts, that must be the anode voltage. And so yeah, so unfortunately though, I could not find any schematics, but anyway, let's take a look at this driver board. I think our CRT is good, and that this is where our issue lies. And as I noted, that cap right there is bloated, and I measured it. It is a 10 volt 1000 mic cap, and it appears to be the S correction cap in the vertical deflection circuit. Alright, so this cap is basically going to be helping to correct for the geometry of the display to make the vertical display a little bit more linear across the entire from top to bottom. And so with this cap not being the correct value, whether in our case it appears to be, and it definitely appears to be an issue, you're going to see that manifest itself on the display, kind of like what we've been seeing, where the display scrunches up at the bottom. And so I think that's got to be our issue. You've got this chip here, which is the TDA 1175, which that's basically what's the driver for the vertical deflection. Okay, that's setting the sweep rate, and that's where all of that control is happening. The horizontal deflection is being driven likely by, or the sweep scan rate is being set by this 555 timer at a much faster rate. This is your horizontal output transistor here. Snubber cap, I believe, is right there, and you've got your filter cap here and your flyback or dampening diode there, and yeah. And so this board, or here you've got another connection to your CRT. I believe these red, blue, and green wiring is for the cathode voltage and your cathode filament voltage as well. And obviously, yeah, this is your high voltage transformer. But yeah, so what I'm going to do is I've already, clearly this cap is bad, measured it, it's not looking very good. I've measured some of these other caps and they appear to be okay. So let's replace this guy. Okay, we've got our new cap installed, soldered in. This is the old one. Out of circuit, was measuring 66 mic, should be 1000, so I think that's definitely our issue. I'm gonna pop this guy back into the display and see if that resolves our display issues. One other thing is just this cooling fan, so I would love to replace that. This is what I'm going to go with. It's 80 by 25 millimeters, 24 volts, ball bearing axial DC fan, 2 wires. This is what I'm going to go with from Mauser. But believe it or not, I actually found the data sheet even for the fan. So between that and the CRT, I'm getting kind of lucky on this repair. All right, let's see if I put this back together properly. There are a lot of connectors in there that their orientation can be easily flipped, so just be mindful of that when you're putting this thing back together. To remove the CRT from the rest of the display unit, you can just loosen this screw here, this screw there, and then you got 4 screws on the bottom, and then this will come forward. You'll have to disconnect this ribbon cable that connects to these buttons that drives that, and you've also got another ribbon cable there. That's the one you can easily flip around, and then of course all the CRT connections. Be mindful of those. Be very careful with the anode connector. I did not disconnect it here. I left it connected to the board, but you could get a nice shock from those. So be careful there. But yeah, let's power it back on. Oh, all right. So you can see that is what we want to see. Look at those look at the icons at the bottom. Clearly visible. Much better than what we were seeing before, where it was all scrunched up. So it looks like we solved our issue. I mean, the screen does look a little tilted. There's no astigmatism adjust or geometry adjust where you can, or I'm sorry, trace rotation. I do not see that there's an adjustment there. There is another pot that's hidden on that little green board. I forgot to share it there, but that's probably a cathode bias adjust. So there's no trace rotation, because it does look a little bit tilted. But hey, at least you can make out everything on the display. It looks great. Might need to. Well, oh no, that's just. See, that's just my camera picking up the sweep rate of the vertical. I was about to say maybe I need to adjust the vertical hold, but no, that's just my camera. It looks great. All right. Well, I think that's going to be a wrap for now. As I said, that fan, I'm going to order that, replace that. As you guys have already saw the test run of it. It's able to run fine with this older HMI. Yes, there is still that vacuum issue, which I need to look into a little bit further, but it's not a huge deal at the moment because we can still run it, and it's just teetering on the lower end of that spec. And then of course, you know, I actually gave the hard drives that I have on hand for the embedded XP HMI to my IT department. They're going to take a look at those, see if it is a hard drive issue or something else. But I'm kind of liking the CRT. All right. Who needs that LCD LED rubbish anyway, right? So that's how you convert one of these from an XP, Windows XP HMI to the older XL series, which it can be done. And then of course we had that issue with that arc suppression cap that is fixed. Now I'm going to, I'm not going to bring this guy quite back into service yet until I get that fan in, but obviously when you really want to make sure that you've got these guys leveled first. Well, you want them secure, right? That's what those feet are for. you want the wheels off the ground and you want it leveled, you know, that's before you start running this thing. So just be aware of that too when you mess with this. But anyway, that's it for this repair video. I hope you guys found it interesting. If you have any questions, feedback, leave it in the comments, and I'll catch you at the next repair.